From time to time, we'll be presented with an oil filter that's been removed from an engine that looks like a deformed balloon. There might be signs of oil leaking from the lower seam, or even a displaced seal. Unfortunately, the damaged filter is a symptom of the real culprit, which is known as over-pressurisation. Welcome to the Ryco Filters Training Academy. When an engine is initially started, its oil pump draws lubricant from the sump before being compressed in the chambers of the pump. The oil is then pushed through a filter where it is cleaned. It then travels to the main oil galleries where it's distributed to all rotating and reciprocating engine components. Because the oil pump is driven by the engine crankshaft, its flow is directly proportional to engine speed. The lubricating system on most passenger vehicles is designed so that their oil pressure remains fairly constant, between 40 and 60 psi, regardless of temperature and crankshaft revolutions. We call the device that is responsible for this task the oil pressure control valve, which is essentially a spring-loaded shuttle or plug. Located after the oil pump impeller, the valve remains closed at low crankshaft speeds, or even when the oil viscosity is low. In the closed position, the valve prevents any oil from returning to the sump, and therefore all flow is directed through the filter. As the crankshaft speed increases, the oil volume supplied by the pump also increases. The oil galleries and bearings create a restriction in the lubrication circuit, resulting in a pressure rise. The control valve spring is what determines the opening point of the valve, so therefore it is responsible for maximum engine oil pressure. Once the oil pressure acting on the face of the valve is greater than the spring force, the return port will be uncovered, allowing some of the oil to return back to the sump. With a slightly reduced oil volume, the pressure within the system will then reduce. The pressure control valve is a very busy yet simple device. Regrettably, it's a moving part, and as such, it's subject to wear, tear, and foreign matter ingestion. The valve can wear a groove in its housing, which will cause it to pivot off centre and become sluggish to move or jam. Unfortunately, this generally occurs in the closed position, as influenced by the control spring. Carbon and sludge build up due to mist or infrequent oil changes, contamination from glycol-based antifreeze, and in some very cold climates, ice formation, are some of the reasons for an unresponsive pressure relief valve. If the valve cannot operate effectively, system pressure will exceed the manufacturer's recommended value, resulting in ballooning of the filter housing. In a worst case scenario, the filter seal can dislodge, or the case can split, causing a sudden and catastrophic loss of oil pressure. While a rare occurrence, the resulting engine damage can be severe, so adequate preventative measures must be taken. If we see any evidence of over-pressurisation, the engine oil pressure needs to be checked against the engine manufacturer's specified values. If excess pressure is found, then the pressure relief valve will need removal and inspection. Filter over-pressurisation is a symptom of oil pressure control valve malfunction and not a defect in the filter. Again, be sure to follow the Ryco Filters Training Academy and develop your knowledge with the market leaders in filtration. Thanks for watching.